I'm Mick Elliott from Electronic Specifier, and I'm here at European Microwave Week with Chris Benker from National Instruments. Chris, can you just talk us through some of the options National Instruments has for the aerospace and defense sector?
Yeah, absolutely. So National Instruments has actually been involved in the aerospace and defense sector for quite some time, and we deal with solutions in both the mechanical and structural tests all the way to the RF spectrum. And in this booth today, we actually are showing quite a few of our RF instrumentation options, particularly our vector signal transceiver. This product is combining the generation capability and analysis capability of traditional box instruments into a single instrument with FPGA backend capability for custom DSP processing. And what that enables is the testing at the parametric level and the system validation level of common mission critical applications such as radar, satellite communications, and electronic warfare. So very hot topics in the aerospace and defense industry. And due to the software-defined nature, we can actually adapt to these mission critical applications as they change over time, such as cognitive radar or wide bandwidth satellite communications.
You also do hardware in the loop testing as well?
We definitely do, yeah. One of the nice things about having both the analysis and generation capability on our instrumentation as well as the DSP on the back end is we can actually close the loop in a hardware fashion in a real-time perspective, both in RF test applications as well as physical test applications. So another example of where we often use hardware in the loop testing is for electromechanical test of, say, turbine engines in aerospace or aerospace applications. Yep.
Okay. Looking at, obviously, you can offer the customers the technology. What sort of benefits do they get in terms of generally about their business in maybe saving time, money,
sure,
and getting the product to market?
Yeah, absolutely. So one of the main goals of National Instruments solutions is to do all of those things, right? Make the costs go down, make test time faster, as well as make the correlation process from design to validation to production a much more compact process, particularly with smaller, more versatile teams. Yep. And so because we can actually change the application capability of our instrumentation as well as the configuration via the modular quality of PXI, we can actually evolve our test solutions with the application in an efficient manner.
And I guess finally, Chris, you're working on the next generation solutions as well here to bring to the industry in coming years?
Yep. Yeah, so absolutely. So we're tracking a lot of the industries. I'm particularly looking at a lot of the RF applications. So satellite communications, which we actually have a talk today in Defense and Space Forum, is an interesting area that's actually merging a lot of the energy and influence of 5G with the traditional orbital satellite networks. And so challenges such as wide bandwidth, high throughput, integration of components and technology are all in volume. We're talking about constellations in the hundreds and thousands, right? These are all new challenges that the satellite industry has to adopt, and at National Instruments we're trying to track those trends and have ideal solutions for those as well. Yep.
Okay, Chris, thank you very much for your time. Appreciate it.
Appreciate it.
Hi, this is Mick Elliott from Electronic Specifier at European Microwave Week. I'm with David Hall from National Instruments. David, we'd just like to talk a little bit about 5G new radio test challenges with higher frequencies, narrower bandwidths. Just tell us a little bit about how National Instruments is helping customers overcome the test challenges in that area.
Yeah, there's a lot of different challenges. I think, there's the fact that 5G is going to millimeter wave specifically introduces new challenges. One of the things about millimeter wave is the propagation, and because of the propagation, you have new technologies like beamforming that are essential to get the signal power over the distance that you need. And so, beamforming introduces some over-the-air challenges. So we're actually showing a demonstration today where we take an actual device and you can rotate it across two axes to see the beam pattern and how that changes as across how the device moves.
Okay. And you've been working with chip manufacturers and various other partners. Can you just talk a little bit about that as well?
Yeah, so the reality is a lot of our customers are solving some of these challenges for the first time just as we are. If we've been in wireless for a long time, and if you go back 10 years, it was pretty faux pas to do an over-the-air measurement because there's certain uncertainties that are involved with over-the-air that you try to stay away from.
Okay.
And so we spend a lot of time educating people on how how to be able to do a conducted measurement. And now when you get to an antenna in package technology, it's not possible anymore. So we have to remove some of those uncertainties in an over-the-air. So a lot of that is hands-on with our customers, helping them understand what some of the challenges are and of course how to address them.
Okay. I mean, amidst all this, we're looking at the FR2 bandwidths, which were obviously at higher frequencies. We've still got the FR1 in action, I guess, around LTE. I mean, there's still a place for that in National Instruments propositions as well, yeah?
Yeah. So, one of the things that we've observed over the last really 12 months or so has been a massive deployment of a lot of the FR1 5G infrastructure. And so the challenges with testing a lot of the FR1 devices are really evolutionary in nature. I mean, you go to a 3.5 gigahertz device, it's a little bit wider in frequency. CERS, there's some challenges like DPD gets a little bit harder for linearizing apart. But in terms of the calibrating and fixturing and the types of measurements you do and the way that you make those are actually fairly similar. So certainly we have a lot of solutions for sub-6 gigahertz 5G testing, and we've been actively deploying them over the last 12 months. But the challenges are actually much more manageable than what we see with FR2.
Okay. What sort of solutions are you offering then, just to be clear?
Yeah, so we have a couple different solutions. So in the lab, a lot of customers will use our vector signal transceiver product line, and that will be used for automated validation or characterization of parts. We have customers that will do huge sequences of tests across temperature and band and different band combinations. They want to see every possible scenario for how that part could operate and how it's going to perform, and so they'll use an instrument for that.
Okay. Okay. And then just looking further ahead, as we're moving, inevitably we'll move to higher frequencies as 5G becomes more and more prevalent. What sort of work is National Instruments doing now to meet the challenges that might come, in 2 to 5 years' time?
Yeah, so there's really a couple different aspects to that. One of them is monitoring which bands are going to get adopted, right? Because there's a lot of potential bands that could be used, but whether or not the infrastructure gets deployed, there is still a question and kind of a decision from the carriers. So one of the things that we're very actively monitoring is actually the 6 to 9 gigahertz band as well. There's some new studies from the FCC in the United States about potentially using those for mobile communications. So those are bands we're actively watching to see if there's some developments there.
Okay, fine. Okay, that's terrific. Thank you very much, David.
Yep, thank you.